Hello everyone. This is a short video about decision trees. It's received a lot of submissions from Module 3, and it seems like quite a number of you are quite understanding how you set up a decision tree and why it's used. So hopefully this short example will help you understand how to create a decision tree and why we use it. So let me give you an example here. So I choose a car example because there were quite a number of you who chose choosing a car as a decision analysis topic. I'll give you an example here. And this was again a very common example I saw among your submissions. I want to choose between three different cars, A, B, and C. And then you have these three cars, A, B, C. They have different colors, maybe reliability. They're rated as high, medium, different power ratings, comfort, etc. You have different attributes for these three cars. And many of you used these attributes and just drew a decision tree or a diagram that uses these, and then to come up with some kind of decision. So the question for you then is, how do you use a decision tree to analyze the decision here? So what is the decision? The decision is ultimately just choosing between cars A, B, and C, or I guess there's an option D, which is don't buy at all. Right? So this is an example where you actually shouldn't use a decision tree at all. You can use some of the frameworks that we learned in the previous module, like the lexicographic framework, etc. Using a decision tree here would be completely unnecessary, and it would be an inappropriate use of a decision tree. So let me change the problem a little bit. So let's change the problem a little bit here. Just choosing a car topic. Instead, I'm going to narrow it down to just two cars to make the calculation a little bit easier here. Let's say I have two cars, X and Y. X costs $40,000, and then so assume both of these are gasoline cars. The miles per gallon rating for X is 34 miles per gallon, and then car Y costs less, 35,000. It's got a lower miles per gallon as well. We're going to assume that the gasoline price is $4.50 per gallon, and we're going to assume that this is true for the time frame we're looking at. Let's say just for the next year. The following usage per year, miles per year. So it's uncertain whether we're going to be driving this car for 10,000 miles in a given year, or 12,000 miles, or 15,000 miles. And so the associated probabilities are listed there, 30%, 50%, and 20% respectively. So a problem like this is where a decision tree will be valid. Okay? This is where you would use a decision tree because there's definitely a decision between X and Y, and there's a set of outcomes with associated probabilities. Right? There's a set of events that basically you cannot control that happens after you purchase the car. Right? So after you purchase the car, you're going to drive a certain miles per year, so you don't have control of that. Okay, so therefore this is where a decision tree will be useful. So we are now ready to create a decision tree. For a decision tree, there are two main components. The first one is the decision nodes or decision fork. We represent this with a square. A chance node or event fork, we denote this with a circle. Decision tree is a sequence of decision or events arranged in chronological order from left to right. So on the left-hand side of the diagram, that happens before whatever you put on the right side. It should be sequential. Okay, so in our decision, the example we're going to look at here is the first thing that happens is you either buy or you don't buy. Right? You either buy X or you buy Y, and then the usage afterwards. These are just events afterwards you purchase with some associated probabilities. It's useful to show the routes by which the various outcomes are achieved. This is really the main point of this entry and the main value of it. The fact that you can map out the possible routes so that if you're trying to kind of figure out what's going to happen many years from now, what would be the best decision today? Associated with each complete course to a tree is an outcome shown at the rightmost end. So at the end of your tree, on each of your branches, there should be a net outcome or net payoff at the end. And then you calculate the expected value going backwards at each node. We'll jump to an example next here. Okay, so we're gonna do this example. Again, I put the relevant parameters on top of the screen here. For simplicity, I'm just gonna assume that the miles per year that we use the vehicle remains constant for the next 5 years. And we're also gonna make the price of gas fixed at $4.50 per gallon for the next 5 years. These are big assumptions, but again, to make this tree simpler, we'll do this. If you relax these consumptions, your tree will just be more complicated. Yeah, but for our demonstration purposes here, we're going to just make this very simple and assume that it's a fixed usage rate for the next 5 years, and the gasoline price doesn't change. One of the first things you got to do in the decision tree is figure out the chain of events here. The first event that occurs in this situation is your decision to either buy vehicle X or vehicle Y. Um, you have to see that that's the first event. Okay. Um, you're driving a certain miles per year. That happens after you buy the vehicle, right? And there's associated probabilities. Right? So we know the initial node here for this tree has to be a decision node. It's got to be a decision node. This, yeah. Let me do that different color. Yeah. And there's only two options, X and Y. Okay. Now, if there are more cars or there's a do nothing option, those just be added. Okay. You shouldn't have any labels inside the square. Okay. You should be labeled on the branches. Okay, and you'll see that why in a little bit. Um, the next thing I want to figure out then is let's assume that you purchase vehicle X. What is the next event? Okay, so the next event is you're going to drive either 10,000, 12,000, or 15,000 miles per year. Okay, that's a chance node, right? It's not 100%. You're going to be driving 12,000 miles per year. There's an associated probability, right? I know that sounds kind of counterintuitive because I guess you decide to drive a certain miles in a given year, but it's really not a decision. It's a chance, right? Because there's a 50% chance that you'll be driving roughly 12,000 miles in a given year, right? Okay, so that's a chance node. Okay, there's three different outcomes from the chance node. 30% for the 10,000, 50% for the 12,000, and then 20% for the 15,000 miles per year. Okay, and again, you should be labeling these probabilities on a branch, and for every chance node, unless there's just one branch, okay, you should be labeling them with the probability, right? If there's only one branch, probably it's one, right? Okay. Let's look at the bottom branch. If you were to decide to purchase vehicle Y, okay, again, it's the same thing, right? It's the same chance node, okay, the probability of 0.3, 0.5, oops, you write that 5 there, 0.5, and 0.2. Okay, what happens next? There's nothing else after this, right? It's the end of our tree, so I'm going to put my vertical bars here. Let me just calculate this for the top branch, and then you could repeat for the other ones. So vehicle X costs $40,000. So the net payoff here, or the net outcome is 40,000 plus. There's also the cost for the fuel, right? Okay. So for any given year, you could the 30% is associated with 10,000 miles. So you drive 10,000 miles per year. You do this for 5 years. Okay. You gotta divide this by the miles per gallon for car X, which is 34. So this relationship should give you the total gallons in the next 5 years that you're gonna need, and we're gonna multiply this number by $4.50 per gallon. Okay. So if you multiply this out, you should be getting roughly 6,617.6. Okay. All right. So we're gonna put that number down here, 6,617.6. So the total cost for this option is roughly 46,617.65. You should use Excel or something, or just use a calculator to calculate this. You repeat now for all the other outcomes, right? So for the second one, it's $40,000 for the car, plus the fuel costs are a little bit higher now, right? Because you're driving more, 12,000 miles in a given year. So you get roughly 7,941.18. And again, these are you can round, it's approximate, right? right? So 47,941.2. And then the last one, again, is 40,000 plus roughly 9,926.47, which is approximately 49,926.47. Now you repeat this for the bottom branch as well, okay? You should be getting around 47,053.6, 44,642.9, and then 43,035.71. Might have flipped this. Let me make sure. Oh, I'm sorry. I have this flipped. It's the other way around. My apologies. So these two numbers are flipped. So the top value is for the 10,000 miles in a given year. So this should be 43,035.7, and the bottom one is 47,000. Oh, yeah, that should be correct. 53. I'm sorry, I have this backwards in my Excel spreadsheet right now. So 3.6. Okay. So now we have the outcome. I mean, are we done? I'm like, no, we're not, right? Okay. We went from left to right to fill out this tree. Now you gotta go from right to left to figure out the expected value at each node, right? So the first place you start is, I'm gonna start over here. I'm gonna find the expected value at this node. Okay. So the expected value at that node is gonna be this probability times this value plus this probability times this value plus this probability times that value. Okay, so let me write that over here. I'll label this as A here, or yeah, node A. Okay, that probability is 0.3 times 46,617.65 plus 0.5 47,941.2 plus 0.2 times 49,926.6. Apologize for my poor penmanship here. And if you multiply this out, you're going to get approximately 47,941.18. Okay. So this value then is 47,941. You repeat for the bottom branch, same thing. Probability times the outcome plus probability, right? So the expected value at this node here, if you calculate this out, it's roughly 44,643. Okay. So in this case, right, you probably want to pay if you're doing expected monetary value approach here, you pick the smaller value, right? Because this is a cost, right? Okay. So you would indicate here, my optimal decision is going this way, and my expected value at this initial node is 44,643. Okay. So the expected value of my decision is 44,643. Okay. And that is my best outcome here. Okay. So this is a complete tree now. Okay. So this is what a decision tree looks like. Okay. Most of you, a lot of you, what you were drawing were basically influence diagrams and some variation of it, showing you how things can affect something else. But again, the utility of a decision analysis or decision tree is when you have a chronological sequence of events with decisions and associated probabilities of certain chance events. That's what makes it interesting. That makes it more valuable. Okay. So hopefully this helps. This is very important as we move on to the next module when we start doing the value of information, and we're gonna now take preferences, like what we said earlier, when I showed you earlier about color and these different attributes. You can now associate with utility. So certain features may have higher value to you, then you have a different utility value to it. Then you can kind of associate those into a decision tree, incorporate into a decision tree to a similar analysis. Okay. So hopefully this helps. If you have any questions, feel free to reach out to me.